Chapter 4 Ratio, Rates and Proportion. Contents. Section 1 Ratio. Section 2 Rates. Section 3 Proportion. Section 4 Ratio, Rates and Proportion. Section 5 Relationship between ratio, rates and proportions with percentages, fractions and decimals. Section 1 Ratios. A. Ratios. Ratio is used to compare two or more quantities of the same kind that are measured in the same unit. The ratio is written in the form of A with double dot B. We read as the ratio of A to B. The ratio of 400 cm to 5 m. We found that cm and m are from the same standard of measurement but in different units. We convert to the ratio of 4m to 4m. Now both having the same unit m. So the ratio is 4 to 5. B. Represent the relationship of three quantities. The ratio of three quantities is written as the ratio of A to B to C. Represent the ratio of 0.03 kg to 500 g to 0.85 kg in the form of the ratio of A to B to C. The ratio of 0.03 kg to 500 g to 0.85 kg. Convert to the same unit first. Maintain the unit G. 0.03 times 1000 equal to 30 G. 0.85 times 1000 equal to 850 G. The ratio of 30 to 500 to 850. We simplify the ratio as 3 to 50 to 85. C. Equivalent ratios. Equivalent ratios are the ratios which having the same values but in different multiples. 1 over 2, 2 over 4, 4 over 8, 1 over 2 equal to 2 over 4 equal to 4 over 8. 2 divided by 2 equal to 1. 4 divided by 2 equal to 2. 2 times 2 equal to 4. 4 times 2 equal 8. This is called equivalent fractions. We can use these relationships to convert the fractions to the form of ratio. 1 over 2 to the ratio of 1 to 2, 2 to 4, 4 to 8, That is, we call it as equivalent ratios. Example 1. Write two equivalent ratios for the ratio of 5 to 9. The ratio of 5 to 9 equal to 5 times 2 to 9 times 2 equal 10 to 18. The ratio of 5 to 9 equal to 5 times 3 to 9 times 3 equal 15 to 27. Equivalent ratio of 5 to 9 are 10 to 18 and 15 to 27. The ratio of 3 to 5 to 8. The ratio of 3 to 5 to 8 equal to 3 times 5 to 5 times 5 to 8 times 5 equal to 15 to 25 to 40. The ratio of 3 to 5 to 8 equal to 3 times 2 to 5 times 2 to 8 times 2 equal 6 to 10 to 16. The equivalent ratio of 3 to 5 to 8 are 15 to 25 to 40 and 6 to 10 to 16. Example 2. Determine whether or not the following ratios are equivalent. The ratio of 3 to 7 and the ratio of 24 to 56. The ratio of 3 to 7 equal to 3 times 8 to 7 times 8 equal 24 to 56. Thus, the ratio of 3 to 7 and 24 to 56 are equivalent ratios. 4 over 9 and 36 over 72. Convert the fractions to the form of ratio. The ratio of 4 to 9 equal to 4 times 9 to 9 times 9 equal the ratio of 36 to 81. Thus, 4 over 9 and 36 over 72 are not equivalent ratio. The ratio of 2 to 5 to 7 and the ratio of 14 to 35 to 49. The ratio of 2 to 5 to 7 equal to 2 times 7 to 5 times 7 to 7 times 7 equal to the ratio of 14 to 35 to 49. Thus, the ratio of 2 to 5 to 7 and the ratio of 14 to 35 to 49 are equivalent ratios. D. Express ratios in their simplest form. How to express ratios in their simplest form? Divide the quantities by the highest common factors, HCF, or multiply the quantities by the lowest common multiples, LCM. If the ratio of A to B or the ratio of A to B to C is a ratio in the simplest form, then the whole number represented in the ratios must at least have one prime number or 1. Example 1. express each of the following ratios in its simplest form. The ratio of 50 cm to 2.6 am. The ratio of 50 cm to 2.6 am. Convert to the same unit, 50 cm to 260 cm, equal to 50 over 10 to 260 over 10. Divide the two parts by 10, that is HCF of 50 and 260. The ratio of 5 to 26. The ratio of 12 to 27 to 48. The ratio of 12 to 27 to 48 equal to 12 over 3 to 27 over 3 to 48 over 3. Divide the three parts by 3, that is HCF of 12, 27 and 48 equal to the ratio of 4 to 9 to 16. Example 2. Express each of the following ratios in its simplest form. The ratio of 5 over 6 to 7 over 18. The ratio of 5 over 6 to 7 over 18 equal 5 over 6 times 18 to 7 over 18 times 18. Multiply both sides by 18, that is the HCF of 6 and 18. Simplify the numbers. The ratio of 15 to 7. The ratio of 0.03 to 0.15 to 0.48. The ratio of 0.03 to 0.15 to 0.48 equal to 0.03 times 100 to 0.15 times 100 to 0.48 times 100. Multiply by 100 to obtain whole number equal to the ratio of 3 to 15 to 48 equal to the ratio of 3 over 3 to 15 over 3 to 48 over 3. Divide the three portions by 3, that is HCF of 3, 15 and 48 equal the ratio of 1 to 5 to 16. Section 2. Rates. A. Relationships between ratios and rates. Rates is the change of one quantity with respect to another quantity. Rates is a special case of the ratios which involve two measurements in different units. In our daily life, we always use the method of rates for the measurements involved in two ratios of two quantities. For example, a car travels for a distance of 40 km. That is, the unit for distance is km. The time taken is 30 minutes. That is, the unit for time measurement is minute. The ratio of 40 km to 30 minutes is written as 40 km per 30 minutes or 80 km per 1 hour or 80 km per hour. This kind of ratio is known as rate. Example 1 states the rate and the quantities involved in each of the following. Ahmed drove a car for a distance of 25 km, which consumes of 2 liters petrol. Rate equal to distance in km divided by volume of petrol in liter, equal to 25 km per 2 liter, equal to 50 km per 1 liter, equal to 50 km per liter. Siti pay 42 ringgit for 3 kg prawn. Rate equal to amount of money in ringgit over mass in kg, equal to 42 ringgit per 3 kg, equal to 14 ringgit per 1 kg, equal to 14 ringgit per kg. Example 2 state the rates and quantities involved in each of the following. That chocolate is selling at 90 cents for every 50 g. Convert the rate to ringgit per kg. 90 cents per 50 g equal to 0.9 ringgit per 50 g, equal to 0.9 ringgit times 200 over 50 g times 200, equal to 180 ringgit per 1000 g, equal to 180 ringgit per 1 kg, equal to 180 ringgit per kg. The speed of the sprinter was recorded at 12 m per s. Convert the speed to km per h. 12 m per s equal to 12 m per 1 s, equal to 12 m divided by 1 s, equal 12 over 1000 km divided by 1 over 60 times 60 h. Convert m to km divided by 1000. Convert s to h divided by 3600 or 60 times 60, equal to 12 over 1000 km times 60 times 60 over 1 h. Convert the divisions to multiplications and inverse reciprocal, equal to 43.2 km per h. Section 3. Proportions. A. Relationships between ratios and proportion. Proportions is the equality of the ratios between two pairs of quantities. Proportions can be expressed in the form of fraction. A car travels for a distance of 10 km in 5 minutes. 10 km over 5 minutes. If the car travels in 60 minutes, 5 minutes times 12 equals 60 minutes. 10 km times 12 equals 120 km. The usage of the petrol for a car is 2L for every 16 km. Therefore, the car requires 6L petrol for a distance of 48 km. 16 km times 3 equals 48 km. 2L times 3 equals 6L B. Determine the unknown value in a proportion. The unknown value in a proportion can be determined by using 1. Unitary method, 2. Proportion method, 3. Cross multiplication method. Example 1. The price of 6 shirts is 144 ringgit. What is the price for 18 shirts? Unitary method. Price for 6 shirts equal 144 ringgit. Price for 1 shirt equal to 144 ringgit divided by 6 equal 24 ringgit. Thus, 18 shirts equal to 24 ringgit times 18 equal 432 ringgit. Proportion method. 144 ringgit over 6 equal to x over 18. 6 times 3 equal 18. 144 times 3 equal x. X equal to 144 times 3 equal to 432 ringgit. Cross multiplication method. 144 ringgit over 6 equal x over 18. 6x equal to 144 times 18. X equal to 144 ringgit times 18 divided by 6 equal 432 ringgit. Section 4. Ratio, rates and proportions. A. Determine the ratios of 3 quantities when 2 or more ratios of 2 quantities are given. If the ratio of P to Q equal 5 to 8 and the ratio of Q to R is 8 to 15, find the ratio of P to Q to R. The ratio of P to Q equal 5 to 8. The ratio of Q to R is 8 to 15. To make it easier for the calculations for the ratio of 3 quantities, write the 2 pair of ratios in 2 rows with the same quantities aligned in the same column. P 5, Q 8, R 15. Thus, the ratio of P to Q to R equal to 5 to 8 to 15. Example 1. The ratio of the age of Ali to Raju is 2 to 3. The ratio of the age of Raju to Roslan is 4 to 5. Find the ratio of the age of Ali to Raju to Roslan. Let X be age of Ali, Y be age of Raju, and Z be age of Roslan. The ratio of X to Y is 2 to 3. The ratio of Y to Z is 4 to 5. The ratio of X to Y equal 2 to 3. The ratio of y to z equal to 4 to 5. 3 times 4. 4 times 3 equal 12. 2 times 4 equal 8. 5 times 3 equal 15. Therefore, the ratio of the age of Ali to Raju to Ruslan is 8 to 12 to 15. B. Determine the ratio of the related value. In a cake recipe comprising of flour and butter, the ratio of flour to butter is 5 to 2. Puan Rosna had mixed 400 g of flour. What is the mass of butter she required to make the cake? The ratio of flour to butter is 5 to 2. If 400 g of flour, what is the quantity of butter? Cross multiplication method. Let x is the mass of the butter. 400 g over 5 equal to x over 2. 5x equal to 400 g times 2. X equal to 400 g times 2 divided by 5 equal 160 g. Unitary method. 5 portions of flour equal to 400 g. 1 portion of flour equal to 400 g divided by 5 equal 80 g. 2 portions of butter equal to 80 g times 2 equal 160 g. Puan Rosna require 160 g of butter. C. Determine the value related to a rate. The parking fees of a shopping complex is 2 ringgit for the first hour. Subsequent hour is 50 cents per hour. Hashim parked his car for 5 hours. How much he paid for the parking fees? First hour parking fees is 2 ringgit. Remaining hours is 5 hours minus 1 hour equal 4 hours. 0.5 ringgit per 1 hour equal to x per 4 hours. 1 hour times 4 equal 4 hours. 0.5 ringgit times 4 equal to x. X equal to 0.5 ringgit times 4 equal 2 ringgit. Total parking fees equal to 2 ringgit plus 2 ringgit equal 4 ringgit. The total amount of parking fees paid by Hashim is 4 ringgit. D. Solve problem. A cake recipe comprising of flour, sugar and butter. The ratio of flour to sugar to butter is 2 to 5 to 6. If Puan Amina plans to use 250 g of sugar, determine the mass of flour and butter in g that is needed. The ratio of flour to sugar to butter is 2 to 5 to 6. Mass of sugar equal to 250 g. Let the mass of flour is F, sugar is S, butter is B. Thus, the ratio of F to 250 to B is 2 to 5 to 6. The ratio of F to 250 equal to 2 to 5. F over 250 equal to 2 over 5. F times 5 equal to 2 times 250. F equal to 2 times 250 over 5 equal 100. The ratio of 250 to M equal to 5 to 6. 250 over M equal 5 to 6. M times 5 equal to 6 times 250. M equal to 6 times 250 over 5 equal 300. Mass of flour and butter are 100 g and 300 g respectively. Section 5. Relationship between ratios, rates, and proportions with percentage, fractions, and decimals. A. Relationship between percentage and ratios. A percentage can be written in the form of ratio. For example, 30% means 30 per 100 and written as 30 over 100. 30% equal to 30 over 100 equal to 3 over 10 equal to the ratio of 3 to 10. Example 1. In a box, the ratio of the number of apple to orange is 2 to 3. Find the percentage of the apples in the box. The ratio of the number of apple to orange is 2 to 3. The ratio of the number of apples to the total number of apple and orange is 2 to in bracket 2 plus 3 equal to the ratio of 2 to 5 equal to 2 over 5. 2 over 5 equal to 2 times 20 over 5 times 20 equal to 40 over 100 equal to 40%. The percentage of apples is 40%. B. Determine the percentage of a quantity by applying the concept of proportion. Ali has 200 ringgit. He gives 80 ringgit to Abu. What is the percentage of the money remain with him? Amount of money remain with Ali equal to 200 ringgit minus 80 ringgit equal 120 ringgit. Let the remaining percentage of the money is Y. Cross multiplication method. Y over 100 equal to 120 over 200. 200 times Y equal 120 times 100. Y equal 120 times 100 divided by 200 equal 60. Proportion method. Y over 100 equal 120 over 200. 100 times 2 equal 200. Y times 2 equal 120. Y times 2 equal 120. Y equal 60. The percentage of money remain with Ali is 60%. C. Solve problem. There are 36 marbles to be given to Ali, Bakar and Chong. The ratio of marbles given to Ali and Bakar is 3 to 2. Bakar received 1 over 2 of the number given to Chong. What is the number of marbles received by Ali, Bakar and Chong? Let A, B and C represent Ali, Bakar and Chong. The ratio of A to B is 3 to 2. The ratio of Bakar to Chong is 1 over 2. Thus, the ratio of B to C is 1 to 2. The ratio of A to B is 3 to 2. The ratio of B to C is 1 to 2. 1 times 2 equal 2. 3. 2 times 2 equal 4. The ratio of A to B to C is 3 to 2 to 4. Number of A over 36 equal to 3 over 9. 3 plus 2 plus 4 equal 9 equal to 1 over 3. 3 times 12 equal 36. 1 times 12 equal number of A. Number of A is 12. Number of B over 36 equal to 2 over 9. 9 times 4 equal 36. 2 times 4 equal number of B. Number of B is 8. Number of C over 36 equal 4 over 9. 9 times 4 equal 36. 4 times 4 equal number of C. Number of C equal to 16. The numbers of marbles received by Ali, Bakar and Chong are 12, 8 and 16 respectively.